Hey guys, I'm Nick and welcome to this new tutorial. Today we will be creating this interesting effect using particles, VDB. It's some sort of a growth effect or disintegration effect if we reverse it. But anyhow, my scene is heavily inspired by this amazingly talented artist Albin Merle. Hope that I pronounced the surname correctly. I apologize if not, but he did this in Blender, and this is something I wanted to explore. I mean, the particles, and I assume that's a volume. So yeah, that could be an interesting effect, and Albin is a damn talented artist, and you can see a huge ton of different artworks in different styles like modeling, procedural modeling. He even shares his project files and models here, so huge respect to this guy and thanks for being such an inspiration. So he did that effect in Blender, and we will try and create something that, in my opinion, follows that workflow with the particles and VDB. We will try that in Houdini as always. So yeah, basically I started with a torus, but then I imported my watch model. So yeah, let's rename it to just to the geo. And let's dive inside. So Alembic watch, it's the watch that I imported. I used it already when I was recreating that multi-layered RBD setup. We need to do a few things. First of all, I want to actually copy this one, and I want to remove all the rotations that I did just so we see it a bit more clear. So I copied that, I hit the delete parameters here, and now we have that watch aligned with the axis. You can see it's pretty big, so it takes 625, but we can convert it to polygons, and then we can drop this match size. In my case, the target size is set to 3, 3, and 3, and I check the scale to fit. And now our watch is in a box that is 3 by 3 and by 3. Actually, it sounds like 2 by 2, but interestingly. Anyhow, we need to attach UVs. So this model that I have here, and let me disable the grid, already has some sort of UVs. We can check it by dropping UV quick shade. If we drop it here, you can see that we have some sort of UVs added. I think that we need a bit better UVs because we will be using the attribute promote, then we will be transferring. So let me just drop a UV flatten right now. So preserve seams and check flattening method spectral. I think it's all default. And then I drop this UV project. So in this case, and we will use UV quick shade once again. In this case, I'm using projection polar, and I initialize it to X and Y plane. And as a result, I have these UVs here, which are connecting in this place here. This is a connection point. So because we will be using some procedural generated textures, noises to be specific, we are not that much concerned about clean UVs, to be honest, because it will be still looking good. So after the UVs, after we have set them, we need to generate the points from which we will generate our VDB. So that's why after UV project, we need to drop the points from volume. In my case, point separation is set to 0.008, which is pretty large amount of points. Jitter scale set to 1 and point configuration set to tetrahedral, and just for your information, we are at nearly 2 million points here. You can see that here we have just 2 point attributes, so position and p scale, and 1 detail attribute. And by the way, we have p scale here only because I have checked add scale attribute here in the points from volume. So our detail attribute doesn't play any role here, but we need UVs. We need those UVs back on our points from vertices to the points. So that's why we drop the attribute promote. We drop that after the UV project, and we connect UV project to the attribute promote. We connect the both to the points from volume, and then we drop the attribute promote and connect the UV project to the attribute promote. And we need to promote our UVs from vertices, or vertices, I assume, to points. And when we have our UVs on our points, as you can see here, then we can transfer them to our points of the points from volume. I'm using the here in attributes of the attribute transform or attribute transfer, sorry. I'm using the point attribute UV, of course, because I want to transfer UV. And for the conditions, kernel function set to wibble and max sample count. And in this case, it's pretty crucial. We should set max sample count to 1, because let me visualize it with attribute from map. So if I go here, if I set the attribute from map, so I think you will be able to see that here we have that rough edge. So these are connected, and these are not connected at all. So what we need to do is be sure that here, if we set it to be max sample count, set it to be like 100, you can see that seam here, and that seam we don't want it to be visible. So that's why let's leave the max sample count at 1, and it's much less visible there, almost visible. All right, so we have our points, we have our UVs on points, we have all the necessary attributes, and let's create the heat groups. These heat groups are the set of points that will be burning from the start, from the very beginning of our simulation. And what I do here is just create 3 spheres. One of them has this mountain node. And yeah, basically I create a group called heat, set the group type to points, and here keep in bounding regions. I said that I want to keep in bounding regions, I want to enable that, and bounding type should be bounding object. So this is our bounding object, because here if I hover over that right input, you will see that it says bounding object. And yeah, basically this is our bounding object. Now to that heat group, we want to create a temperature, and I drop an attribute create and select that I want to create temperature attribute for the group heat. And for the group, and here's the deal, it will create that attribute for all the points, because you cannot create attribute for just a set of points, right? For all the points, the attribute temperature will be created, but only for the group that we specify here, it will be set to the value that we write down here. And in my case, I'm setting the temperature to be 1 at the points that are in the group heat. And then I have my pyro source spread, and this is pretty interesting, because the denser your points are, the bigger diffusion rate and search radius and max neighbors and all that stuff, the bigger it should be. Because let me show you. Of course, you can try different parameters here, and it also hugely depends on your time frame of the animation, because I wanted it to be nearly fully burning at 210 frames, and that's why I set the rate to be 6. And basically, the bigger these values are, rate, search radius, and max neighbor, the bigger they are, the faster the pyro will spread, the fire will spread. Here in the combustion, I also set the ignition temperature to be 0.2. For the fuel, it's so default, I think, but yeah, for this temperature, we need to drop a file cache, and I want to show you how it actually goes. It is pretty fast. You can see that each frame, it expands to a significant number of points. And yeah, the frame 210 actually, it is almost done. So yeah, there's no such a thing as like correct values, because it will be different for you because of heat groups, because of particle separation of your volume, because of the maybe noise type. Here I'm using sparse convolution and element size set to 0.2. It's all very different, and you should play these simulations and see how they actually expand. And then of course you can file cache them and drop this out temperature just to kind of finish that logical chain, the chain of nodes that are performing one logically connected operation. So it's all good, and now we have our particles that are burning. So what I want to do now is drop a popnet after our out temperature. So here's the deal with this popnet. It's very default, but there are a few things that I want to show you. So of course, first of all, in the source first input, emission type set to all points, geometry type, geometry source set to use first context geometry. And for the burst, I wanna emit these particles once, only at the frame number 1, which will be once in our animation, of course. So then we wanna drop the subsolver. What this subsolver does is that it allows us to grab parameters from this sub level, because popnet, we dive inside, we are at another level. You can see that obj, geo1 and popnet, and it's one level deeper than these nodes here at the geo1 and the sub level. So we need to drop a subsolver, and solver means that it basically solves it reads or writes, it performs any sort of an operation with the given information each frame or each substep if you want. But the main thing about this subsolver here is that we want to dynamically pass the temperature into our popnet, because if we just like bypass that subsolver, we will know only about the temperature at the frame 1. We won't know anything about the parameters, the attributes that changed in the sub level, in this level. So we go into the popnet and we go into the subsolver. So what we have here is we have our dop geometry. This is basically this. And then I can merge in my out temperature, this one. Same number of points, but here we have that attribute, that temperature attribute, which is always changing because the pyro is spreading. So now if we go into the popnet, into subsolver again, I have this attribute wrangle. So this dop geometry goes into the 0 input, and this object merge goes into the first input. And I want to set the parameter, the pop parameter called stopped. I want to set it to be true if the temperature is less than 0.3. But we need to grab that temperature from the out temperature object merge, because it will be correct one at that given frame. So this add stopped means that we will use that function called point, and here you can see that it reads a point attribute value from a geometry. So we read the temperature value of each point of the geometry at the first input. So, and here you can see auxiliary input 1, 2, 3, and so on. So it goes 0, 1, 2, 3. So basically it means that stopped will equal 1 if temperature is less than 0.3, and vice versa. And stopped means that it won't react to any forces of wind and drag and etc. So I want to show you a few frames of this simulation, because here you will clearly see that we are affecting only the particles that were burning in these first frames. Unfortunately, the color is not spreading out after the popnet, but we can always set this color. I would say here, let me go and select the visualization type known in the pyro source spread, but here we will talk about this PT dist, but we can always kind of visualize it here. So you see how these particles are activated because of the temperature that they receive from the pyrosource spread. So yeah, the particles that are stopped in the popnet receive no forces. The particles that have temperature more than 0.3 receive the pop wind, which in this case, wind velocity is set to 1 at z-axis, amplitude set to 0.5, swirl size to 0.3, and after that we also have drag, which is default air resistance set to 1. So we file cache all of that, and now we wanna write some very simple VEX code. So the main logic behind this whole setup is that I want to scale the particle based on its distance from the initial position. So as these particles are flying away because of the wind, I want to scale them down too. So what we can do is to create the distance variable, pt dist in my case. So here you can see that I'm creating variables called curp, which is current position, and init_p, which is initial position. And current p is that position that we have from our popnet. And you see it's plugged into the zeroth input. And if we are referencing to the input number 0, or like this first and most left input, we don't need to reference it with this expression point. But in the second input, or input number 1, we have our out temperature, which is initial position, which is not affected by the wind. So what we want to do is again use that point function that we will use to read the p attribute of the first input of and read that from each point and reference to that each point with a pt_num attribute. So the pt dist again is not a local variable, it's an attribute of the geometry, and it is equal to the function that basically calculates that distance. It's called distance, and it returns the distance between 2 points, as you can see here. So we drop the init_p and current p into that distance function, and now we have distance. And you can see here I'm creating this attribute pt dist, and here in the color I'm referencing that attribute here, pt dist, and color type should be ramp from attribute, and we are ramping from range 0 to 1. So as you can see, the bigger the distance, the whiter these particles are. So yeah, I think should be clear with this distance attribute. It's very easy, not so much wax, but there is one trick here. So with the p scale, and here it gets a little bit more complex, but don't worry, I will explain you. So p scale, right? The scale of the point of the particle. What the hell is this? This is the exact copy of our points from volume point separation. I can copy parameter, go to the set p scale, and here we go, paste relative references, and it removes actually everything. So Command Z, but basically that's how you can get it. Anyhow, we can create a variable from it actually. So what do we go? Command X, then here we go Command V, and we can create a variable, call it float particle sep equals that channel. So now particle sep should be here. So what the p scale actually is, I want to get some number that we will be subtracting from the initial p scale. So initial p scale is equal to the particle separation, so it's 0.008. And here I I will show you how manipulating these variables actually influences our VDB, but what I want to do is I want to remap the particle distance, that PT dist that we already created. I want to grab it into the function fit. We can probably, because it will be easier for you to understand, but PT dist, that local variable. So PT dist goes here. So we want to remap the value of PT dist, remap that to be from 0 to 1 to be 0 to, in my case, 0.08. And then we get this remapped range. And I mean remapped, it means that it won't go from 0 to 1. It will be going from 0 to 0.08. And we can get this range here, that remapped value, and subtract that from the particle separation. So then, yeah, I'm using retime here just to revert it back. But what I want to show you with the VDB from particles, and it actually about this P scale here, but let's just briefly go through the VDB from particles because it's very default here. So what I'm doing here is VDB from particles. Voxel size is the copy parameter from the particle separation. Point radius scale 1, minimum radius in voxel 0. Then I go and add VDB reshaped SDEF, operation set to close. VDB smooth with the operation set mean curvature flow and 6 iterations. And then I convert it back to polygons. And let's talk about that PT dist here. So let's focus here. And I want to show you that if we create this fit range of PT dist, if we set it to be 0.008 as our particle separation, you will see that it's too much. So that's why if we maybe go with 0.01, we still have more shape. So I mean, we are not subtracting enough because our PT dist is remapped to the too low values. And I want to show you how the amount of detail is actually decreasing here. And I think the more the amount of detail here we will have, the more kind of organic it will look here. So just see how it's actually changes as I change some values here. And of course we can go and subtract, remap it to be from 0 to 0.1, and then it will be very kind of low key, not that visible. Yeah, I just suggest you playing with the value just until you find the correct one, because at 0.2 it gets just smoother, you know, we are losing some details. I want it to be pretty, you know, organic and pretty melting, you know. So yeah, 0.08 it is, I think. Yeah, definitely. So after that, convert VDB, of course we wanna enable our retime, and now we can go to some sort of 180. For the retime, of course I'm using fit range. Output frame range is set to 210 and input frame range set to 1 to 210. So for the attribute transfer here, because we still need to get our UVs back, we don't have them here on the mesh, we just have them here on our retime SOP, the last SOP that we used with our particles that have this UV, because we already did the UV transfer here in the attribute transfer. Now we will need to get those UVs from points back to our mesh. We can do that by using attribute transfer again. Same conditions here, but attributes. And here I want to show you that we need not only UVs, but also PT dist. And I will share with you a bit later why we need that PT dist, but we need that for texturing. So then, after we did this attribute transfer, we are safe to file cache it all and have that beautiful disintegration result, or some sort of. This one is more like a growth, right? If we disable the retime, it will be disintegration. But so anyhow, I wanna blur the PT dist and then apply the color to the PT dist. But in this case, range will be from 0 to 0.1. For the attribute blur, attributes, of course, PT dist, blurring iterations 20, step size 0.5, pin border points should be unchecked, influence types should be set to proximity, and proximity radius should be set to 0.6. And then you can probably skip that attribute blur if you want. I just think, yeah, I don't know. I think it looks better with the attribute blur though. And yeah, the color, again, rem from attribute. The attribute should be PT dist and 0 and 0.1. If we go 0.05, you can see that we don't have that full range. And at 0.05, yeah, it still works at 0.05. Yeah, I just thought that 0.1 also works good. So that sounds like that's it. We have everything that we need, and here you can see how that PT dist, you see here, as the VDB starts eroding. Yeah, we have that PT dist, and we will take a look at some creative ways to use that PT dist. But essentially that's our setup. Now, of course, let's talk about the cameras, lights, and of course the shader. Oh, and almost forgot that I have animated the camera. If we look at it here, it's just like zoom out. That's it. And then I also have my geo, like my original geo, that just spins. And that's it. Let me just highlight the color here. And yeah, that geo just spins a bit. So that's it. And it's a linear motion. It's not like Bezier curves. So yeah, camera is set to 125 focal length and resolution is vertical, 1080 by 1920, using for graphic exposure, depth of field, blah blah blah, all these cool redshift effects that I missed when I was using Octane. But yeah, grid should be also here. There is a thing with the grid, but we will talk about that a bit later. For the lights, and I assume we should try and enable our redshift and hope that we won't have a crash here. Waiting for the shaders to compile. You can see that we have our grid, but we don't see it here, and that's because I have here in the redshift OBJ in the visibility tab, I have unchecked that primary ray visibility, because if I enable that, you can see we have that background. But if we uncheck just primary ray visibility, it means that our geo, our watch, will still get all the reflections, all the shadows, all the ambient occlusion from our grid. If I disable second ray visibility, then it will ignore all of these reflections, GI, and all that stuff. So yeah, you definitely want to keep second ray visible if you just want to remove the background but don't want to lose all the reflections. So yeah, now to the material network, and this one is interesting, not with the grid, I assume, because it's just a grid with some sort of a bump map and yeah, some sort of gray color. Let me just switch the views back to vertical, and here I want to new pane tab type redshift render view. So just because we wanna save a bit of space, and let's get back to our sort of complete look. So here are a few things in the material network. So material blender, I'm using two presets that go into the material blender. It's iron and glass, and I'll be honest with you, they are almost default. In glass, I just upped the roughness a bit, and for the iron, I used two noises, max on noise that is set to wavy turbulence, octave set to 10, and a super important thing is to set the source to be UV vertex attributes, and vertex attribute name should be UV. and I'm using that for the roughness channel. And for the bump map, I'm using the RS Maxon noise, which is set to Nucius, octave set to 5. Same thing, UV vertex attribute should be set to source, and vertex attribute name should be UV. This prevents the textures to kind of float away when our VDB will be eroding. So yeah, that goes to the bump, that goes to the roughness, and that's it. But the main thing here is that material builder. So this RS from, I don't think that we actually need that, but hey, this particle attribute lookup. Remember that we have our color data bind to our PT dist. So everything that is closer to be eroded will be white, and everything that is not eroding right now will be black. So we get this particle attribute lookup. We don't actually need that into our glass, I think. We just need to refresh our render, I assume. Yep. So the particle attribute lookup goes into the blend color of the layer 1, which is our glass. So whenever the particle color is white, we will be using glass, and whenever the particle color is black, we will be using iron. That's how you can mix shaders with this very useful particle attribute lookup. All right, and yeah, I think that's actually it. We have our watch face advected, I assume, or created, or grown. But yeah, anyhow, let me know if this tutorial was helpful. If you have any questions, please feel absolutely free to leave me a message in Discord channel. Better to use Discord. You can leave me a message in Patreon. You can write me an email. I will be very glad to help you out, guys. I think this is a really super cool effect, and I want you to know how to do that. I want you to use that in your commercial and personal projects. I am super grateful that you are here with me on my Patreon. You allow me to dedicate my time to create these tutorials. I am doing my best to provide as much value as I physically can, and I'll be back next week with a new tutorial. Bye!